Okay. So have a look at. We are just about to start dimensions now, right? What is a dimension? You already know. But the powers of the fundamental units. Powers. Why do we call this as powers? Just there is a big reason behind this. Because we are in a 3D dimension, world of 3D dimensions. We have heard of 3D. 3D means three-dimensional. What is the meaning of the dimension here? The basic dimension you may find is the length. Length of this cube. The length. Right. The width of this cube. And the height of this cube. You can see those all. Can you remember the figures you used to draw in your O levels? Sorry, not O levels, like we have like Montessori age, year 1, 2, 3. So there might be exceptional characters. They know how to draw the 3D stuff. Even I used to know, like in grade 5 or 6. I'm not a good artist, but I used to know how to get the 3D shape. But some others take it like 15 years to understand the difference between 3D and 2D. So majority of you guys just draw a person likes of the structure in 2D way. If you ask to draw a bus, you may draw a bus like this way. I can still remember the first 3D diagram I drew was a bus. I drew one. When I was like 5 years old, I happened to know, it should be drawn like this way, not the flat line like. So I drew something like this. See, it's all, I had the perception of how to deal with the 3D world. So somehow 3D, here these are 2D. Why do we call these ones as 2D and 3D? Because the dimensions, length, width, and height. These are the visible things. But anyhow, it is a derivative of length, right? Length. Another dimension is there. What is that? A mass. You may say your mass like weight. We used to call it like weight. Actually, it should be mass. Like 50 kilogram, 60 kilogram, 80 kilogram, 100 kilograms, 200 kilograms, like that. Anyway, මගේ නම් 65යි බර 65 kilograms. Like that. Mass, length, mass. The next thing is time. You may ask if you are really anticipating to leave the class earlier. So the classic during time. So the basic three things are what? Length, mass, and time. As the units, you know, here the dimensions is going to be the powers. I will tell you why do we call it like power. So if you take certain just length, what is the dimension of this one? We consider it like L. I will tell you why. And the area, length into width. So this is also a length. This one is also a length. So it's going to be L to the power 2 like this. This is a very rough explanation. How to go deep into the stuff. So write this. There are 7 basic SI units. There are 7 basic SI units. And according to the basic SI units, according to the 7 basic SI units, their own dimensions are also there. Write this in a new line. But in the A level scope, මම ඕවා මේ අර ක්ලාස් එකේදී නම් ඔක්කොම කිව්වා 7ම කියලා දැම්මා. මෙතනදී එහෙම කියන්නේ. අපි ඕන ටික විතරක් ගමු. In the A level scope, we just only consider what? we just only consider dimensions of mass, length, and time. මම ඔය ටික උන විතරක් ගන්නවා ඒ ඇති මට. Physical quantity, right? Unit and dimensional symbol. Dimensional symbol. Mass. What is it? It's kg. But here the dimensional symbol, it is a mass, so we take it like capital M. Right? In the same way, length. What is the unit? In meters, but dimensional symbol, it's a length, so we take it like capital L. And the other one is time, measured in seconds, but the dimensional symbol is going to be capital T. Mass, length, time. We took the uppercase letters only. That's it. Copy this. This calls it quickly. අර දේවල් කිසිම වැඩක් නැහැ මම ඒවා ටියුට් එකේ දාලා තියෙනවා ඕනනම් බලන්න මම ඕවා ගැන කතා කරන්නවත් කැමති නැහැ ඇති වැඩක් නැති Now write this in a new line. Write this. The construction of dimensional equations to find out the dimensions of physical quantities. Right, physical quantity. Have a look at. You know the length, L length. First thing is length. You already know it is in capital L. Yeah, this is something you already know. But when it turns to area, how about it? Area. Number one, what is the step you need to know? Now put this in a line, in a new line. Firstly, how to write the equation, physical equation. What is the equation? Area equals to length into width. So in words or even, area equals to length into breadth. Length into breadth. That's great. So now the next step is put a square bracket around the one that you are finding dimension. How to put a square bracket around the one that you are just about to find out the dimension? That's A. This is what I'm trying to find out the dimension of A. Right. What is it going to be here? Length. It is capital L. This one is capital L. So the dimensions of A is what? L to the power 2. remember to put this bracket, square bracket, that stands for what? Finding the dimensions of, this square bracket stands for what as a symbol? Finding the dimensions of this A. Understand? Such a really very simple stuff. Okay? I hope that you have fun. Done this. Done or not? Done or not done. Okay. Let's move back to our usual board. This is really hectic. Right. Let me write that same example back in this board. It might help you a bit, not just bit, a lot. You know that length, it is capital L for a length. Right. But here it's like for area. What is it? The first step. Write the equation. Area equals to length into breadth. What you just trying to find is A equals to L into B. So here I'm about to find out the length of A. Here I'm going to put this one as L and L. So A. Dimensions of A is L to the power 2. This is what dimension it is. කොච්චරක් එයා span වෙලා තියෙනවද කියලා. What is the span of that? Might be a fraction, like so half, 1/3/2, or square root of 3/2, whatever it can be, any number that comes to there, that's the dimension. That's it. The contribution of that dimension to construct certain physical quantity is known as what? Dimension of that one. ඒ කියන්නේ යා කොච්චරක් වැඩේට සහභාගී වෙනවද කියන එක. ඒ කියන්නේ සමහරු ස්ක්වයර් වෙලා සෙට් වෙනවා, කියුබ් වෙලා සෙට් වෙනවා, fraction half වෙලා සෙට් වෙනවා, square root of half වෙලා සෙට් වෙනවා. එක එක විදි වලට එයා සෙට් වෙනවා වැඩේට. right? එක එක විදි වලට එයා සෙට් වෙනවා. එයා සෙට් වෙලා තියෙන විදිය අපි ගන්න ඕනේ. එයා ඉන්නේ කොහොමද ඒක හොයාගන්න එක තමයි ඔය dimensions කියන්නේ. මහා අමුතු magic කියන්නේ නෙමෙයි. Right, let's find few of these. Like in the same way, I just spent some time on doing the unnecessary thing in the first half an hour, something I have done in the early. So it might be a good help to you. Even now, you can just use the knowledge of finding out the dimension. So, however, let's find it here. Volume. For volume. Like in the same manner, I will only write the equation form. Make a length into breadth into height. Right. What I just need to do is find out the dimension. How do I say that? By putting a square bracket. So now find and tell me. I will give you 20 seconds. That's more than enough. Yeah, MS key has done. So here, what will I do? L by L by L. So my dimension is nothing other than L to the power 3. That's it. Very good. Now the next part is, once I found that one, let's find density. Density. Find it. Find it. Dimensions of density. If you have forgotten, I will write it like density is the mass per unit volume. In another sense, so something filled in there. Density equals to mass over volume. This is what my equation. Now, right, fine. Good key. Twenty seconds more. How to put it like this? This is capital M for mass and volume I just found, L to the power 3. The finalize the answer, I will get it like ML minus 3. That's simple. Now for the Stokes law, eta of what? Stokes equation. Or what? Viscous coefficient. As I told you, you have to neglect all what? Numerical values. Write this. First law, you find that here is, let me write the equation. F equals to 6 by eta RV. Right. This is what I want. Now write this point. Dimensions of all numerical values and numerical constants like pi. Right. The important point is dimensions of all numericals. And numerical constants. Numerical constants are always what? Always equals to 1. Not 0. It's always going to be 1. This is something you have to know. Normally in theory class, I gave it like taking my time. Here I have no extra time. So I will teach all the theory in terms of questions. Question එකත් කරනවා, theory එකත් කරනවා. This part has to be removed. This reduces to something like eta RV. Now I need to find out the dimension of eta. What should I do? F over RV. And for the F, what is it? So sorry. No, there is a technique. If you have forgotten the dimensions directly, you can write kg ms minus 2 as this one. This one as what? Meters. And this one ms minus 1. So one can be cancelled off. This becomes kg m minus 1 s minus 1. So firstly obtain what?
units. That's really easy to remember. Then substitute relevant dimension. What is it? M, L, T thing. So what is the numerical dimensions of coefficient of viscosity? M, L minus 1, T minus 1. This is how it really is. Can you just understand how did I find it? Okay, good. Really good. Very good. Give me 1 second. හෙට A level නිසා මට ඉතින් පොඩ්ඩක් වද ඔයාලට කන් ලියන්නකෝ. ඔයාලා ප්‍රැක්ටිස් කරන්න ඕනෙම නම් මට ඉතින් දෙන්න පුළුවන් මොමන්ටම් වල දැන් මෙතන ෆෝස් වල එහෙම වෙන වෙනම හොයන්න ඉතින්. ඕනනම් හොය මොනේ ඉතින් හදිස්සියක් නැහැ. ඒ ටිකත් හොයලා මම දැන් මෙතන කෙලින්ම ෆෝස් ගන්න නැතුවනේ කෙලින්ම ආවේ. නෑ ටිකක් ගමු. right. මම මේ ටිකක් තප්පර කිහිපයක් දෙන්නම්කෝ 10ක් විතර එකපාර දීලා දාන්න. මෙන්න මේ ටිකේ හොයන්න ටක් ගාලා. Find out the dimensions of these ones that I'm just going to give you now. Find out dimensions of circled one, circled quantity in the following equations. Okay, first one is P equals to mv. So you know what is P. This one you have to find out. M is mass, M stands for mass, and V stands for velocity. This is one. The other one is force. F equals to ma. F is force. M is what? Again like mass. And A is acceleration, right? The next one, W equals to FD. Now I am only writing what is D. D is distance. You need to find out this one. And in the fourth one, P equals to W over T. You need to find out this one. And I will only write T as time. Right? In the same manner, I'll give another thing. Okay, now you found these ones enough, and P equals to F over A. This is another P. This one is momentum P. This one is what? Power P. This one is pressure P. A is area. Right. ඔන්න සෙට් එක හදලා දැන් මම තව එකක් දෙන්නම්. මැද්දට දාලා දුන්නේ නැහැ එකක්වත්. I'll give something like in the middle. F equals to Gm m over r to the power 2. You need to find out G over here. Right, try this. ඔන්න ඔය 6 හදන්න I'll give you like time for 1 minute per each, considering 1 minute per each. The maximum time allocation that I can give this one is like some 6 minutes. Your time begins to click now. Write down, start it. Last 4 seconds and time is over. Right. So for the first one, we'll use this color, finding out what the dimensions of P. What is the dimension of P? M LT minus 1. Why? So you know the velocity. What is velocity? I didn't give you to find out the dimension of velocity yet. What is dimensions of velocity? Velocity, you know the distance over time. Distance is L and this one is T. So the dimensions of velocity becomes LT minus 1 when you are finding the dimensions of V. So I didn't do that earlier. So how to find out the acceleration? So it is also velocity over time. So the dimensions of acceleration is going to be, so the top part is going to be this one, LT minus 1 over time T. So the finalized stuff is going to be LT minus 2. This is what the dimensions of what? Acceleration, if you want to apply. So here you need to find out the acceleration part to here. Dimensions of force is, what is it going to be? Force is mass M multiplied by LT minus 2. This is how it is. Now this one you have to substitute over here. Just found. So how would I? Sense of work done is going to be ML T minus 2 by L. So the finalized dimension is ML square T minus 2. මේවා එකක්වත් කටපාඩමින් නම් තියාගන්න හදන්න එපා ළමයි. ඇති වැඩක් නැහැ. කවුරුත් අහන්නේ නැහැ. Right? In this part, you have to substitute this work done over to here. The power is work done is what? ML square T minus 2 over time T again. So this comes up. What is my finalized dimension? It's going to be ML square and T minus 3. Now here the pressure. For the pressure part, you have to find out this dimension and substitute over to here. This one. So the dimension of pressure is going to be ML minus T minus 2 over L to the power 2. 1L cancels off from this one and only one remaining. So what is the dimension of P is going to be now? ML minus 1, T minus 2. That's how it really is. Harini? Right. Now for the next part. Bye. Yeah, good. Here, first thing is you have to subject J equals FR square and M by M. Get this one. Done. F is something ML T minus 2 and L to the power 2 divided by M to the power 2. 1M and 1 cancels, so 1 comes up. So the unit be M minus 1, L to the power 3 and T to the power minus 2 is the dimension of what? Dimensions of universal gravitation constant. What? Universal gravitational constant. Copy this. Done. That's good. Great. So we have to use the knowledge of what? Dimensions to find out some quantities without dimension. So put a subtopic like saying dimensionless plus physical quantities. One famous one is known as radian. Radian, or in angle, plane angle. How? That's defined in this way. How? Arc length is over this one rad. So I gave you that. So what about it? Dimensions of theta is going to be what? S over R. S is in a length, capital L. This one is also in a length. The final thing is going to be 1. Final thing it is going to be 1. Can you just understand it? Yeah, good. The very next most thing it is coefficient of friction. Coefficient of friction. And this one is also a force. Also a force. So what is it going to be? Again, it's going to be ml t minus 2. Cancel off both. The result is again 1. Harned. Okay. Now write relative density. Can you understand it? Right. So many things like relative humidity, refractive index, those things have no dimension, right? I totally leaned on that. Now write this in a new line. And apart from this, and apart from this, and apart from this, and apart from this, numerical values, numerical values and numerical constants like pi, numerical constants like pi and exponents. You may find what is an exponent, x to the power n something or e to the power something in a box. These are known as exponents. These are what? Exponents. This is an exponent, this is an exponent. So these type of things, or logarithmic values, LG something, logarithmic values, or trigonometric identities. Trigonometric identities like sine theta, cos theta, tan theta, whatever, all contains what? Write this in a new line. All of above mentioned categories, all of the above mentioned categories belongs to dimensionless quantities. Dimensionless quantities. Dimensionless quantities. So can be finalized. So can be finalized. So can be finalized. Can be finalized in the way of. Can be finalized in the way of. Dimension of 1 for them. මේ හැමෝගෙම dimension එක කීයද? Dimension is equals to 1. මේ හැම එකේම dimension එක 1. බිඳුවනේ මේ මතක තියාගන්න 1. It's not 0, should be 1. Right. Have a good look at real example. E equals to half mv square. In this case, you don't want to consider here. Remove it. This whole as 1. This whole set as what? 1. There not. What can I do for this one? Remove and consider it as 1. All as 1. Like this. Any value you find as any of these, like a numerical number like this, you can consider an exponent or any sine theta, cos theta, and a logarithm. You just eliminate the stuff using what? 1, not 0. It is 1. ඔන්න ඔය කියන කතාව තේරුණාද හැමෝටම? Right. Very good. Very good. Right. අපි පටන් ගමු එහෙනම්. ඊළඟට තව පොඩි දෙයක් තියෙනවා ලියන්න. A dimension never express what? Never express what? Express what? The magnitude of the quantity. Magnitude of the quantity. It does never express the magnitude of the quantity. It just says what? It just says the nature. Only express what? Express the nature. Unless like units. Units are always expressing the magnitude. Like we say 100 centimeters, we have an idea. But when you say L, see, likes of a length of 5 meters. The dimension is what? Still L. From the sun to Alpha Centauri. What about it? It has like 4.3 what? Light years. It's also mentioned like see L. So you can never get any idea about the magnitude, right? About the magnitude. Copy this and say, Yani, you can't compare a length by another length. Because why? Because why? It doesn't say. But in units, you can't just write the unit. You have to write with the numerical value. It gives an expression. But for dimension, it just gives what is the nature. It is a length. What is the nature? It is an area. What is the nature? It is a volume. What is the nature? It is a force. What is the nature? It's something like with coefficient viscosity. So what is the nature? Like that. But you can't understand what is the magnitude from it. Arida? Arined? And write this in a new line. Another example, right? A little girl who is like 10 kilogram. You minus it like capital M, right? Another huge lady. Huge lady who is like some 150 kilogram You still mention it like capital M. You can't compare. Can't compare. Can't what? Compare. Can you understand? You can never compare using the dimension. තේරුණානේ? තප්පර 10කටත් capital T, අවුරුදු 100කටත් capital T. ඕකත් දාගන්න. හරිද ළමයි? ළමයි හරිද? හරි. හරි. ලියන්න මම මේ කියන එක. right. අපි දැන් අන්තිමට කරේ මොකක්ද? We just did like comparative nature. All right. There are certain dimensions which may also cause problems. Giving the similar dimension for what? Different physical quantities. Good example is omega. What? Angular velocity. You don't know what is this? ඔයාලට තියෙන ලොකුම පැටලිල්ල එකයි. අම්මට සිරි අමුතු සීන් එකක් දුන්නා angular velocity අපි දන්නේ නැහැ. හරි ඉතින් තව අවුරුද්දක් විතර යනවා ඔයාලා angular velocity ඉගෙන ගන්න. Because 2023 guys just finished that. So ඔයාලා ඉගෙන ගන්න එපා. Like 2 months earlier they finished. So you have a lot of time. Angular velocity. And it is like in rad s-1. Okay. So the problem is the dimension of omega is, but only radian has dimensionless. I told you earlier, radian has no dimension, the angle has no dimension. Already given one page. See, the radian, the angle has no dimension. Only dimension is there for what? So it's like this. Theta over time. Theta has no dimension, nothing to worry about. It's like 1 over capital T. So you get it like T minus 1. In the same way, for the frequency, these are two different things, extremely two different physical quantities. It is also 1 over T. Your answer is T minus 1. These are not equal. These are what? Extremely different. එහෙම පිටින්ම different. So nothing to compare about. Everything is completely different. හරි නේද? It's extremely different. හරි. තව තියෙනවා. මේ විතරක් නෙමෙයි. ලියන්න the work done and the work done next conclusion. The work done. Work done. And what? Moment. Moment has the same dimension. Has same dimension. Dimension. How? Let me show you. The work done is like force into distance. It's like what? M L squared T minus 2. Let's see the moment thing. You know this thing in grade 10. Force multiplied by the distance. What is it going to be? Momentum and torque equals the dimension of torque is what? Force multiplied by distance again. It is again ml squared t minus 2. But not the same, but not the same. මෙන්න මෙහෙම ප්‍රශ්නත් මෙයා අපිට ඉතුරු කරනවා. හරි නේද? It may leave some of these problems to us. තේරුණා කියලා මං හිතනවා. I believe that you understood some extent. Okay, good. Hari. I will give you like a break of what maximum of 15 minutes, 20 minutes. Now get you a break and join back around 2:35. Right? Join back around 2:35. Just mute yourself and go enjoy your interval. Join 35.